Imagine a world where no one believed what they saw with their own eyes. A world where people thought the earth was flat, the sun revolved around the earth, and diseases were caused by bad air. This was the world before the Royal Society, a group of scientists who changed everything by saying, "Don't take anyone's word for it, see for yourself." This simple idea, known as the motto, Nullius in Verba, sparked a revolution in how we understand the world. In 1657, a young man named Richard Jones, who would later become Lord Ranelagh, went on a journey through Europe with his tutor, Henry Oldenburg. This trip wasn't just a tour, it was a scientific mission. Ranelagh's high rank opened doors to the salons of French scientists, where Oldenburg and Ranelagh joined in discussions on a wide range of topics. These topics included everything from the source of popular opinions to the nature of the brain and the stars. These discussions were part of what was known as the Invisible Colleges, informal groups of scientists who shared ideas and discoveries. Oldenburg, who was deeply influenced by these discussions, returned to England with a vision of a more masculine community of science. He believed that science should be based on facts and experiments, not just words. When he arrived in London, he found a city buzzing with the return of King Charles II. This return marked a new era of stability and order, and with it, a renewed interest in science. Under the king's patronage, a group of English scientists met at Gresham College on November 28, 1660, to found a new academy for the advancement of the sciences. This academy would become the Royal Society. The Royal Society was a unique institution. It was not limited to the elite and respected residents of one city. It was a truly international community. Scientists from all over the country and the world could contribute to its work. John Boyle, for example, could write from Herefordshire about orchards and cider, while John Flamsteed wrote from Derbyshire about astronomy. Even though they couldn't attend meetings in person, their ideas and observations were valued and discussed. Oldenburg, who was appointed secretary of the Royal Society, played a crucial role in making this international community a reality. He had traveled extensively and spoke several languages, which allowed him to communicate with scientists worldwide. His job was to organize the scientific observations and experiments, write letters to foreign scientists, and ensure that the Society's tasks were carried out. He developed a network of young embassy staff who could send reports through diplomatic channels, making the communication more reliable and extensive. The letter became a vital tool for scientific communication. Unlike books, which were large and easy to censor, letters could slip through unnoticed. They were also cheaper and faster, often sent via the ordinary post, which operated between major cities like London, Paris, and Amsterdam. Oldenburg's network of correspondence included scientists like Johannes Hevelius, whose observations of the moon and solar eclipses were published by the Royal Society, and French physicians who kept English doctors updated on the latest medical debates. However, the rise of vernacular languages posed a challenge. For centuries, Latin had been the universal language of science, but with the spread of literacy and the rise of national languages, scientists had to read and write in multiple languages. This made it harder to communicate and share ideas. Oldenburg tried to overcome this by promoting translations and using mathematics and universal measurements to create a new common language. The letter, with its informal and fragmentary nature, became the ideal way to share scientific discoveries. It was inexpensive and allowed scientists to spread their ideas without the need for a publisher. Oldenburg, recognizing the power of the letter, combined it with the reach of the printed word to invent scientific journalism. He published the first issue of the Philosophical Transactions on March 6, 1665, which aimed to share the latest scientific discoveries and ideas from around the world. The Philosophical Transactions became a model for modern scientific publications. It was interrupted only twice during Oldenburg's lifetime, once by the plague, when the issues were printed in Oxford, and once when Oldenburg was briefly imprisoned in the Tower of London for a few careless words. Despite these interruptions, the journal continued to thrive and became a cornerstone of scientific communication. The Royal Society faced many challenges in its early years. Science was still closely tied to religion, and new ideas were often seen as heretical. Defenders of the Royal Society, like Bishop Sprat and Joseph Glanville, had to prove that the Society's work was innocent and beneficial. Glanville, in particular, argued that the Royal Society had done more to advance practical knowledge than any philosophical ideas since Aristotle. The Royal Society's emphasis on experimentation marked a significant shift in the way science was conducted. While older scientific language aimed at meaning and certainty, the new language of experimentation aimed at precision. This shift from experience to experiment was revolutionary. It meant that scientists no longer accepted ideas just because they were old or widely believed. Instead, they tested ideas through careful observation and experimentation. This new approach to science led to many important discoveries. For example, Robert Boyle's experiments on air pressure and the behavior of gases laid the foundation for modern chemistry. Isaac Newton's work on gravity and optics revolutionized our understanding of the physical world. These discoveries were made possible by the Royal Society's commitment to experimentation and the sharing of knowledge. In the end, the Royal Society's motto, Nullius in Verba, became more than just a phrase. It became a way of life. It encouraged scientists to question everything, to see for themselves, and to test their ideas through experiments. This approach has led to some of the most significant scientific breakthroughs in history, from the discovery of penicillin to the development of the Internet. The Royal Society's legacy continues to inspire scientists today, reminding us that the best way to understand the world is to see for ourselves.